Hi, I'm Deying from Zhejiang University, and I'm here to share our recent study, Touch and Go, a design and fabrication method for 3D printing touch fastening structures. Touch fasteners can be found throughout our daily lives. From outdoor rain jackets to cable ties, they provide temporary fastenings that is reliable and easy to use. Inspired by touch fasteners, we propose Touch and Go, which is a type of structures for FDM 3D printing to achieve temporary connections that are reliable and customizable. For the majority that have access to 3D printing, adhesives such as hot glue or duct tapes are the go-to solutions for connecting two 3D printed parts together. However, these current methods generally do not allow disconnection afterwards and may produce cosmetic issues like groove marks. And for those methods that allows repeated disengagements such as rigid joinery, snap fit joint, or mechanical fasteners, they typically require special design features that are not always applicable for every models. Additionally, off-the-shelf touch fastening products like Velcro or 3M command strips work great in many scenarios, but the connection relies heavily on adhesive substrates which are susceptible to bonding failures over time. And these products are hardly customizable besides cutting and trimming. Therefore, our goal is to create a universal solution for 3D printing temporary connections. Current studies in HCI and maker community provide great insights for our work. Connections created through means of digital fabrication such as CNC, laser cutting, and 3D printing has greatly enhanced the variety of objects makers were able to create. However, some of these proposed methods offer limited fastening capabilities, while others are designed to accommodate certain model shapes. Meanwhile, avid makers on many online 3D printing communities have shared a great deal of designs regarding 3D printing touch fastening structures. However, these designs are shared in mesh files that are difficult to modify, and the existing parametric design tools offer limited customization. Therefore, another goal for this study is to develop a design tool that provides various customizing features for different design needs. Now, I'm going to introduce our design method, which contains two layers, the profile and the pattern. The unit profile refers to the shape of the individual fastening structures. There are two categories of profiles: the extruded units and the taper units. The extruded units are the result of extrusion of a closed planar shape. They are cylinder unit, tilt unit, and slot unit. Another type of profile are the taper units, which are the different combination of cylinders and conical frustums. The difference between the extruded units and the taper units can be explained during the engagement and disengagement process. The extruded units have a steady increase of resistance, while the taper units provide different force feedbacks depending on the shape profile. Here are the design examples of different profile. This piece of clip art is designed with cylinder units, which is the most stable unit and offers great wear resistance over a prolonged period of use, so you can readjust the combination of these elements however you like. This decoration board contains a patch of tilt units. The upward tilt offers better shear resistance, and when you attach a downward tilt structure such as the anchor hook here, it performs better in terms of the weight-bearing capacity compared to the cylinder unit. Another example is the wall organizer, which is equipped with a slot unit. What's special about the slot unit is that you can choose between the locked mode and the sliding mode. The locked mode offers similar fixed connection as the other units do, while the sliding mode grants single degree of freedom, where the connected objects can perform linear motion. The washband is an example where touch and go structure can be deployed on a curved surface. The taper unit ensures secure connection during wrist movement, but can be easily detached the way you would peel off a Velcro tape. The second layer of design is the unit pattern, where users can select different array types, which are rectangular and triangular. While these two patterns that are designed for static connections, Touch and Go also provides a great new way to connect moving parts together, the dynamic pattern. It grants rotational and linear movements between two parts, using pattern design that is similar to a train track. The windmill here is one demonstration of the circular dynamic pattern. As you can see, when you blow air to the windmill, it starts to rotate and picks up speed instantly, which shows that both the reliability of the connection as well as a relatively low resistance between the two parts. The toy car here is another application for the circular dynamic pattern. Here, the car is pressed down with considerable force while moving forward. The safety drawer here is an example of force customization through adjusting the pattern density. The drawer here on the left has a denser pattern than the one on the right, so they can form a stronger connection to prevent children from opening them accidentally. And last but not least, the gray cloud on the bonsai clip art is an example of linear dynamic pattern. To enable users to easily customize touch and go structures to their needs, we developed a design tool that can adjust unit profile and pattern, as well as estimating the fastening capacity of the design. The first step is to import the model. Then, the user can select the target surface to generate touch and go structures, which will be highlighted in green. After selecting the surface, the user can choose the structure primitives, which include the unit pattern and unit profile. Finally, adjust parameters for certain primitives, such as tilt angle, unit height, and pattern density. The tool will then give an estimate of the holding force, and here we have the result of 10 kilograms. And this is all about touch and go. Thank you for watching.